This video is an introduction to section 16.7. I want to make this fairly quick so you can read through this section on your own. Remember back in chapter 12, we had this equation for relative acceleration. This was acceleration of b is equal to acceleration of point A plus the acceleration of b with respect to A. So we're starting off with this equation. And we're going to take the acceleration of b with respect to A and break it into tangential and normal components. Now, the reason we're doing that is back at the beginning of this chapter, we talked about two different coordinate systems. One is fixed at point A. We have point B, which is rotating about point A. Now, point A is moving also, but you can treat the relative motion as just B rotating about point A. So you have a normal component of acceleration and a tangential component of acceleration. Then, using equation 1614, which we had back here, okay, so you have a tangential component and a normal component. So if you replace the tangential and normal components with what we have here, that gives us on the next page equation 1618. Okay, now this is general plane motion. So this is a vector equation, and you're going to have two different components in your vector equation for general plane motion. So let's say you have an x component and a y component. You can use this equation then to find two unknowns. But if you don't know anything about the direction of acceleration b, your two unknowns would be the x component and the y component for that acceleration. If you know the direction but not the magnitude, then because there's a relationship between the x and y components and the magnitude and direction, if you know the direction, then you just have one unknown here. So if there's another unknown on the other side of your equation, you can use this to find the magnitude of acceleration b and that other unknown. Sometimes you don't have to look at both the x components and the y components of this equation. If you just have one unknown which you're looking for, you may be able to look just at the x components or just at the y components. So you could start off by writing this equation down and just putting in everything you know, or you could be a little strategic and think beforehand about what you know about the direction of the different vectors here and what you're trying to figure out, to see if maybe there's a approach that is quicker. Okay, so that concludes the introduction to section 16.7.